When you actually see it, it threw me off.
Oh, really?
Yeah, actually,
How are you? Hey, Chris. Yeah, so basically understand some of the maybe I will I'm marveling at this wonderful term. This is great. Yeah. People care about their data. Right, yes, perfect. So go ahead and grab some more pizza before it gets totally cold. And I just discovered the bag of drinks is mostly full. So if anybody wants a soda, go right ahead. So anyway, hi. Welcome, everyone. It's my privilege to welcome to this official Seamless Astronomy Colloquium and to welcome Kristine Portman, our honored guest here to the observatory, which she is visiting for a month, and also to the Data Science Initiative. And we have to thank Charles for bringing Chris to the Center for Astrophysics, so we should all be very grateful to Charles. Thank you, Charles. And just to explain, for those of you who don't know, Kristine Portman, she is the distinguished professor and presidential chair in information studies at UCLA. I have to look because they keep giving her more titles. Anyway, to me, she's the world's expert on what should we all do with our data. It's a one-sentence summary of who Chris is. But she's written books that are important in our world. The most recent one is called Big Data, Little Data, No Data, Scholarship in the Network World. The one that first made me aware of Chris's work was called, or is called Scholarship in the Digital Age, which is what I think we all do. So that's why so many of us are here to hear from Chris. Many of us may not know that Chris is also the chair of the visiting committee for the Harvard Libraries. So if anybody has anything to say about the Harvard Libraries, you should tell her. She's got a very long list of awards, but the few that I chose to point out that she's actively involved with in these honorary positions is she's on the Library of Congress Scholars Council. She and I were on the founding version of the National Academy's Board on Research, Data, and Information, which I understand is much more active since then, and is aligned with something called CoData, which she will probably explain to you that she's also involved with. And the way that I get to work with Chris these days is she has a big grant from the Sloan Foundation for something called the Center for Knowledge Infrastructures. And that center studies astronomers, among other groups of scientists, as if we were tribes. I kid you not. Anyway, and so I think that Chris is going to illuminate us about all of that work. Thank you so much for coming, Chris. Thank you.
Great privilege to be here. Again, many thanks to Charles for welcoming me as a non-astronomer. My new office mate, who I don't see her yet, assumed I studied gravity. So this is good. So I'm fitting right in very, very quickly to the group. But thanks to Alberto and Michael and Alyssa and all the ADS group and the library for the invitations to be here. I've got two of my team from UCLA today in the back corner, Bernie Bosco, and Bernie's studying astronomy, and Irena's just finished her dissertation on biomedical data sharing. So we're covering a lot of different disciplines, including some work in earth sciences and undersea biosphere and so on. So we're pretty broadly spread. We've been looking at scientific data for the last 15 to 20 years across different disciplines and in astronomy for about the last decade. So what I want to do in the time we have today is just start a conversation with all of you about why I'm here and why it was such an exciting opportunity to come and be in the midst of one of the world's great centers of astronomy and astrophysics for a month. So with that, most of you, probably all of you, are familiar with this move toward requiring data sharing and data release. And these policies have been evolving since the early 2000s in various countries, various agencies. They're pretty much pro forma by now. They vary in detail, they vary by discipline, embargo period, so on and so forth. But there's something on the order of requiring people to release data as condition of getting grant funds in most countries, certainly in the Western world, and pretty well embedded in China and Asia and others moving in those directions too. Australia is very active in this area. We're also moving along fairly quickly on implementation. Merce is one of the authors of the FAIR principles. This came out about 2 years ago. And again, it's an ideal, it's a set of principles, it's a place to go, but every one of these is a very multi-layered, multi-dimensional challenge to deal with. What does it mean to be findable? What does it mean to be accessible? Accessible versus retrievable versus interoperable, and so on. And we'll come back to what some of these things are. So this is the ideal. And similarly, the ideal is that we're developing this beautiful virtuous circle where you will do your research, you'll create your publications, create your data, each one flows into the next. And I think it's suitable that the reuse is the gray one, because that's a really, really gray area. And that's the title of our big Sloan grant is, if data sharing is the answer, what is the question? So we have been focusing on that for the last several years of, all these big pushes toward data sharing, but data sharing to what end? How do you actually make those data reusable for some other purpose by some other individual or community in the long term? This is much more what the reality is. And as one of your Seamless Astronomy papers said, it's not so much data release 1, 2, 3 as graduate student 1, 2, 3. And that's pretty much the way that the flow of data works nowadays is, we have these beautiful grand ideas, but it's the graduate students and postdocs who actually do a whole lot of hands-on, not only in astronomy and astrophysics, but in biology and the other areas that we study as well. Plus, a lot of the software and code is written by people who turn over in a pretty rapid rate. So maintaining something that is findable, accessible, interoperable, and reusable, given the rate of turnover, is one of the larger challenges that we're looking at. So wouldn't it be nice if we could just plug that Ethernet in the cloud and have it all work nicely? We could have a couple and everything else. But this is much more, the reality of data migration. It's looking for the hammer. And we're all looking for hammers in data migration. And that's a lot of what we do in information retrieval and digital libraries, is some of these issues of thinking about how you actually get data from one state to the next, one system to the next. It's a perpetual process of migration. Are there more chairs? There's a couple more chairs back there. So why is astronomy so interesting out of all this? So here's a number of reasons why astronomy is interesting to us. Is this real continuity that the current systems today are, Galileo's observations are in them. You've built up incrementally, and there's a lot of cross-referencing of these. Astronomy was one of the first fields to go pretty heavily digital from the 1970s onwards, and it's some very important historians of science will look closely at what is this method changes in practice in astronomy as it's gone. Very international field. All of you move around and you have collaborations that span both the continents. There's a lot of data exchange across these communities. But at the same time, none of this is completely steady. There's various processes of renewal of funding and these consensus mechanisms. So you've worked out a way much more than most other fields have of building something that looks like an infrastructure to manage the knowledge of the field. Also interesting to us is the long-term continuity. This is not intended to be comprehensive in any way, but more of an example of how over time a number of very large and important units have been built up, and they interoperate with each other pretty well in a lot of different ways, in a lot of different partnerships. So this is just 1960s up to the kinds of things that we're building today. So I'm going to put questions up now that I'm thinking about here, and let me just briefly describe them as a setup, and then I'll talk more about the infrastructure and examples and come back to these at the end. So the overarching questions are at the top and the bottom of what does the knowledge infrastructure look like? What are the components of it from the perspectives of many players? Different people in this room, different people in these buildings, different partners that we have here. Because what we've found in our various studies is that infrastructure might look pretty durable, pretty stable from the outside. These are tools and systems that you use every day, and a number of you are involved with actually building and operating them. But in the long run, they're actually pretty fragile. Durability is an accomplishment. It's not something that one should ever take for granted. You often don't see until it starts to break down. So Bernie's driving question for her dissertation is pretty much this one: how do astronomers keep their data alive? I'll give you some examples of what's meant by aliveness in a few minutes. We see invisible work everywhere. What is in between that plug and that cloud? There's a whole lot of people. There's libraries, archivists, people in this room who are maybe not very visible. Their names may be in papers, but they're the ones that are doing the work to keep these data alive and to keep them useful to other people over generations. We have several papers in progress just on the notion of invisible work. We talked about some of those in the January or February meeting that we were out. Path dependencies. Is this an economic term? Is this familiar to people? No. Okay. It's the idea of decisions that you make early, and actually, Charlie and I have talked about some of these things. The decisions you make early in the data cleaning, the ones you make early in your choice of pipeline, the ones in the design of things like ADS, will determine what you can do in the future. You can start with very granular data. You can re-aggregate later, but if you start by aggregating, it's very difficult to disaggregate or to add other features down the line. So this is there's a lot of things changing in astronomy and in internet architecture and so on now. So decisions that you're making today are going to have long-term implications. So we're looking for some of those. And then just how these these externalities that the world in which we all live are affecting and evolving as we work for the long term. So those are, they'll keep me busy for a month or a year, another career, keep them going. Those are the kinds of things that I'll be talking to you about over that time. The first astronomy project that we started with about 10 years ago was working with Alex Zale and the Johns Hopkins group on the Sloan Digital Sky Survey, and specifically with the first two phases of Sloan as that funding was ending and other people were carrying on for phases 3 and 4 and beyond. And so here's some good examples of path dependency. The choice was to make these data open to everyone from the beginning. That's one of the big claims to fame that the Sloan Digital Sky Survey has made. But remember, they did it with partnership with Microsoft. Okay, so the Terra servers that became the Sky server, and it's now becoming the Psi server more broadly out of Johns Hopkins, is the way that they built this thing. And one of the reasons Alex asked us to work with them is because he was learning that as you get to the end of active data collection, it's very hard to get a funding agency to pay to help to keep the data alive. You can get money to build the data archive, but to keep it, and he's had lots of people tell him, as other people have found in other areas as well, is, well, you've got the data, what's the problem? As opposed to, we've got spinning disks, we've got programmers, we've got interoperability, we've got lots of things, to keep these data alive over the long term. So that was one set of decisions. Then we started looking at LSST, which also is a contrast versus winding down that first phase of Sloan and winding up LSST. Now this, of course, is order of magnitude larger with the amount of data involved, and they have put about half of this $1 billion is dedicated to building the data archives. So again, a choice of where are you going to invest to keep these available for the long term. Considerably different models, but long term, somebody's got to pay for those data. So you pay up to be part of the consortium, you have access to data immediately, and they're going to negotiate the next. But they're trying to do this on open source software, which raises different kinds of maintenance questions as far as how the community is going to keep these data going over the long term. So different relationships. And you put these two together from the time that Sloan was conceptualized, proposed onto the planned end of LSST operations, and you've got several careers worth there already. And a number of people went from Sloan to LSST operationally to work from one to the next. So how do you think about building all these pieces to work together when you've got this many generations of telescopes, of software technology, of scientific questions, of different funding structures, and the rest of it? This is a very interesting long-term infrastructure. We're also working with a group at Keck, and as you would probably be aware, Keck telescopes are run by the University of California and Caltech primarily. This week, I just grabbed this yesterday, this week is the 25th anniversary of first light. Yeah, of these, in 1993. Yeah. It's good timing on grabbing this line for that. So here we are, 25 years on. Now look at these dates. 2015 is the 10-year anniversary of the archive. The archive didn't even start until 12 years after first light, which is a very different set of decisions that were made around Sloan or LSST or Hubble or Chandra and so on. So the astronomers who started around first light, including the ones that we're working with, had to do all of their own data management, and so there's nothing approaching a comprehensive archive of what's available. And it's a much different kind of operation than a Sky survey, of course, too. But we're working with Andrea Ghez group, and this is where there's a lot on Bernie's shoulders here of helping them keep these data alive for yet another generation. But they have managed, because the time-based approaches of their work, to keep these data alive for almost 25 years now. And then the early stuff is speckle data, and now it's the very advanced adaptive optics work that they're doing. But they have, because they need to see the orbits coming back around the black hole, they've got to keep analyzing and reanalyzing these data through many different migration and interoperability shifts. And so she's been working very closely with this group for the last couple of years, and this is what her dissertation is about. She's interviewed some of you here this week, and Alyssa's the external on her committee, because we needed an astronomer on the committee, but it would be a conflict of interest to have anyone at UCLA on her committee. So looking at the kinds of things that we're working. So we have many bridges of the international nature of astronomy. We're also diving deep. Bernie and Michael Scarton, our postdoc, put this up last week and has been interviewing people around FITS and looking at a lot of other issues, because if you want to look at infrastructure, you need to look top down and bottom up too, and look at these relationships. And we'll talk about these later, and this will be a nice little piece of her dissertation as well. But FITS is, shall we say, a mature format by now. So Fortran base goes back to the late 1970s, and yet we're continuing to build on this. So it's got a very large installed base, but it was built for something for a very different scientific and technological environment than what we're working with today. This is, I warned up there, I had a couple of little slides. And this is going from, I was here for the 20th anniversary, so this is 25th. 1993 was a big year for us. But of the many milestones in here, I want to point out the first one, which is that ADS did not come up as an independent service. ADS came up as part of the infrastructure from day one of the tying it into the SIMBAD database, and the assumption that it was not enough to have just the publications. You need to have the publications and the objects linked to each other. So we've also spent time working with the CBS folks and looking at that. And they're also very active in the Research Data Alliance. Francine Berman, the founding president, is right here. So we're doing lots of data things around as well. Now this, lots of infrastructure decisions here. Now the mapping of SIMBAD to Gaia, new catalogs added. And this is a very interesting to us in information science and metadata questions, because they have mapped all the different names that are used for different objects. So there's, as of yesterday, I checked again, 7 million names for 9 million objects, whatever. But the thing is, this is also the beauty of infrastructure. This happens in the background. If you search under one of those names in Chandler or in Hubble, it's going to go to Strasbourg, match up those names, and if it was in any of 30 different names, it's going to find it and bring it back to you invisibly. And you don't see that, but that's part of this set of political and technical and all kinds of other arrangements that have allowed people to work together over time. And we're really not seeing these kinds of partnerships in other fields as much as we have here in astronomy. Again, thanks to Alberto and Michael for letting me copy some slides over time. You could put almost anything in the middle here. It's really just a network diagram, but again, to point out that we can look at this infrastructure from many different perspectives, and usually when you're looking at one part of it, you're not explicitly aware. It's that invisible work that's keeping all these pieces working together. And similarly, keeping these pieces working together. So the publications, the objects are really pretty well curated in astronomy, and and you've got here observations and objects. This is where the libraries are trying to deal with the pieces. And Dana and I had a good first chat yesterday about some of these things. Of it's not just getting the observations and the objects and the publications. It's also the software, and it's the instruments, and all kinds of layers of interoperability involved here of keeping all these pieces alive and working are impressive. It works at all. The virtual observatory, we've had many interviews about, and many different players, and we haven't really written any of that up yet. It's very complicated and very contentious, and we're still looking at what we can learn. Also, kind of a general question is, the virtual observatory was funded out of the 2000 decadal survey, so 20 years ago. And how would it look if you were, bidding it today? How would you think about it? Probably in a very different way than you did 20 years ago. So let me kind of wrap up and get back to those general questions. Sort of what we're learning so far. So astronomy infrastructure has a number of very durable components that have held up pretty well over time. There's a deep sense of collaboration, considerable openness that has allowed these frameworks to build, a lot of international coordination. The data have long-term value, although it certainly does vary from project to project, astronomer to astronomer, it's, some people need 25 continuous years of data. Other people can get, kind of one shot and one night on a telescope, you get one paper to some groups, and it's a very different kind of cumulative nature. So looking at the different kinds of astronomy and how those pieces are coming together. A lot of agreed on standards, and Bernie and Michael dug into this on FITS about just what is agreed and what's not, but again, quite a bit. And then a number of shared resources, and then the layers. The fact that we agreed on FITS means other things can layer on top of it. The fragility is perhaps the more interesting part of, and looking for what pieces are more or less fragile. The investment varies considerably by mission. We're certainly seeing that space-based missions are investing more in data stewardship than ground-based missions. We've had a number of people comment on that. It's not really clear to us why there's such a distinct difference in long-term commitments to those. But it certainly varies from the scale of mission and the kinds of instruments that are involved. And the access to the data varies. So the data coming off the instruments is generally available after some amount of embargo time and various agreements. But the derived data, the data that you're taking maybe from multiple telescopes, multiple missions, bringing together and doing new things with them, those are not, it's not necessarily a good place to put them. People are sticking them on their websites, they're spinning under people's desks, they're kind of all over the place. There's a lot of interesting derived bits of data that go with particular papers that are pretty hard to find. A few more things on fragility is the curation varies quite a bit. How much, some of these things are open source and readily available. Some are more proprietary. We're seeing a movement in some arenas, more proprietary tools to more Python-based, more open tools being picked up. But a lot of differences in local pipelines, and certainly the data coming off the instrument, which may then go into multiple pipelines and diverge, and that raises interesting questions of what are the data at the end of the day. We found copies of the Longitudinal Sky Survey scattered all over the world. They just kept kind of popping up. We thought we knew what the Longitudinal Sky Survey was. I've got a copy, I took a copy to do this or that. And of course, those copies are diverging. They're not just mirror copies over time as people process them differently. So you've got various kinds of investments, but just like it's easier to get a donor to pay for a building operating costs, it's easier to get money to build a new instrument than to keep an archive going. And keeping an archive going is a very expensive process, as people in this room certainly know very well. So conclusions so far, before I go back to those the methods and questions, are that the durability is an accomplishment. We should assume that things require continuous investment, continuous kinds of visible work to keep them going. And the visible, you see the instruments, you see the institutions. It's this massive amount of invisible infrastructure that Bernie and Ren and my team are looking for. What kind of information work is going on to see how these data kept alive and who invests where. How do we do this? We are we don't look for big data numbers. We look for much more qualitative kind of work. And we start usually by collecting kind of all the documents, physical and digital, that we can get our hands on. We do a lot of background work. We like to do kind of fairly formal hanging out. So I'm kind of hanging out as an ethnographer, so I would like to have an office in these buildings here. So we can just get a feel for who's doing what and how the place works, and read the posters in the hallway and come to the talks and see how things are. So being embedded for long periods of time. I don't see enough of Bernie or Irena, because they're really spending more time out with their groups than back writing with us. So we do a number of different kinds of interviews, and we're comparing sites over time. And I would assure you that everything we do is completely covered under human subjects, and that's why we have these multi-page forms that we ask people to sign, and people in this room already signed this one. but we do protect it very well for our knowledge, our reuse. So back to the questions. So this is the kind of things, we've got another 20 minutes or so.
Yeah.
And I've got a month, so.
I don't think we're gonna sit here for a month.
We're not gonna sit here.
Just check, okay.
It's an experiment. We can sit here for 20, 30 minutes.
Yeah.
There's still seats and drinks back. So these are so I think that gave you enough picture of the kinds of things. We can talk about these. We can talk about specific data issues. We can talk about whatever you want. While we're here is, I want to think with you about just what astronomy, knowledge infrastructure is, and see from the different standpoints of the people who are working at the Center for Astrophysics. And looking for the durability and fragility of these, the notions of what's keeping data alive. Randy's found that an extremely valuable question to ask and to get conversations started. The big data, little data, no data book. I just went around and asked people, what are your data? And I bet I got enough for several books. I'm just asking people, what are your data? And going from there. Okay. So I'll look for what this invisible work is. And there's a number of people in this room who I know do a whole lot of that invisible work to keep it going. I want to look for the kinds of decisions that are being made today that will enable and constrain things for the future, and things that might be different if different decisions had been made a year ago, 5 years ago, 20 years ago, in terms of what you're able to do right now. And then ask, how these movements toward open access, open science are changing the way that you think about some of these things. So let me, I've got thank you slide, and then I will just go back to the Mosaic. So, thank you.
And then I'm pretty sure what Chris is asking for is your questions and your answers to these questions initially. And then we will have to have another gathering in a month to find out what she learned.
Yeah. Now, questions on any of this?
Yeah, I have a couple of questions. And thank you. It's really nice that you're going to be here for a month. So, we'll enjoy that very much. So first, you're focusing a lot on data, but specifically within astronomy, and it's the same for a few other fields. The software, the code is a big part of the data. Sometimes it's difficult to distinguish. So there's been a lot of focus in the last years on building archives and best practices, like the FAIR principles, the citation, and so for data. But now there is a lot of movement for the software, building those archives for accessibility to the software, having the documented record. So I just was wondering your thoughts about that and how much you're going to focus also in understanding what do we need to do for the archival of the software so that we understand the data better. The first question. And the second question is at what point from instrument, again, in the context of astronomy, for data that come from instruments from long ago, like 3-4 years ago, and so you would say, well, it's important to archive it, but in terms of alive has a different meaning. Might not need to produce a lot more results because it has already exhausted everything that it can produce, and then it doesn't need to be accessible in the same way online, or at least not as immediately as it would be for more recent data that have not been yet analyzed. What would be the differences about that, and at what point we say this is archived data that you can access along your way?
Okay, each of those questions are book. So let me
We'll work on that.
We'll work on that book. So the first question about focusing on software, absolutely. We learned early on that if you don't have the software, you don't have data. They're deeply coupled, and this is something that Dana back here is working on from a library standpoint. Is who does that archiving, how to put those pieces together. And James Howison was at the meeting last week. I think he's been working on the software archiving. And Vince Cerf has gotten very interested in that, and some others at Google. And there's this whole group within RTA that's looking at that software.
I just have to interrupt for 1 second because I forgot to do something at the beginning. We have another distinguished expert guest this month. So this is Francine Berman, who you may know used to be the head of the San Diego Supercomputer Center and has done a lot of other things for infrastructure in computing and science. So she's sitting quiet, but some of these questions may actually wind up for her. She's a cold. Anyway, go ahead. That's why Chris keeps going like this. She's pointing at Francine. Anyway.
Well, and you two have worked closely because Marisay is also very active in RDA. So there's a lot of groups working on that, and so I was hand waving over data and infrastructure as encompassing all of that. But yes, you've got to look at them together, and because they don't all move as a piece. Each one has its own kind of temporal scale and different licensing, different control, and if you've got proprietary software and you've got open data, and you've got all these things, the combinatorics are daunting. So there's definitely people working on that. We're trying to focus on the data, but we're not by any means claiming that it's independent of the software. And then the other about how long do you need to keep it? That again is one of those kind of terabyte level, $1 million terabyte level questions of. It's a classic in sort of libraries and archival science is you've got an 80-20 rule, say in a library of 80% of the use goes to 20% of the material. If you knew in advance which 20%, you could buy that 20%. But even if you did know in advance, it's a moving window because what's useful now is different than what's useful 5 years from now or 10 years from now. And also like your work on the undiscovered of things like the diaries of people in the 19th century about when the flowers bloomed turned out to be extremely useful for climate change questions. So it's very hard to think about that. But it's also hard to think about just sort of what is the archive. We have papers that are kind of long overdue, that we have drafts that will be out. Looking at because they've seen these drafts about the Sloan Digital Sky Archive was transferred to 2 different major research university libraries about 5 or 8 years ago, and they were running out of money, and it was the end of the project, and they passed the data sets off and said, see what you can do. They gave a little bit of money, memorandum of understanding, almost identical, and said archive it. And what happened at the end of the 5-year process is what the 2 libraries thought meant to archive was completely different things. Okay. So again, these papers are going into review. But one of the libraries took the data set literally and tried to get a slice of it and put it into a dark archive, which meant you could keep the bits alive, but it wasn't scientifically useful. And the other one focused on keeping all the documentation, the records of how the data set was actually built, figuring if you ever want to interpret or reconstruct it, that was the more important part. And as long as the disk kept spinning, that was good, but when the disk died, at least you had that archive. So they really diverged in different directions. So we've analyzed what went on, what was the institutional culture of what it meant just to archive, which turns out to be pretty broad too.
Right. Just to be sure, I don't mean that to throw away the data, but I just mean there might be a much cost-efficient way of archiving all the data than
I'm sure there is.
For
Yes.
a community.
Yeah. Okay, let me get Fran and then the woman in white and Phil back.
I was just curious because if you think about all of these areas, what are your thoughts on sort of best practice? If I think about the astronomy community and the way they use data and whether it does or does not provide competitive advantage, and contrast that to LSST to CERN or to the big Alzheimer's database that NIH has funded. Each of those sort of exists in an ecosystem where you can think about best practice. Are there some commonalities that you're finding?
So the question is best practices, and we're putting that in terms of knowledge infrastructure. What does the infrastructure look like, and what choices are being made? So that's and you were there when I gave that comparison talk for the SciData Cloud a couple of years ago, starting to make those comparisons. We're finding a few aspects that are pretty comparable. Things like certainly the invisible work and some other distinctions about what data actually are reusable and independently and which ones you really need to collaborate around. We're seeing commonalities. But a lot of the questions about data is deeply embedded in the kind of science. So and even physical sciences and biological sciences have quite a bit of difference. In the physical sciences, you've got more precise measurements, and you've got things that are easier in many respects to come back and compare over time. Where with some of the genomics data, they would rather keep the sample and reanalyze it because the technology is changing so fast. So a 5-year-old data set is pretty useless of old genomics data, but if you got the sample, you're going to reanalyze it. So part of that is also a difference between observational data, which are generally more worth keeping, than experimental data if you can rerun the experiment. So simulations and stuff like the NCAR, the National Center for Atmospheric Research, those don't tend to be kept more than 5 years or so because the software and all the rest of it keeps going. I talk to people in astronomy who will say that I've got these brilliant simulations I would love to get back to, but I went from this postdoc to this postdoc to this postdoc, and 2 postdocs later, I have no credentials on that machine. And even if the data were alive, I couldn't get to them because nobody gave me access to them again. So there's a whole lot of other stuff going. And that's why we're looking at this infrastructure. There's a whole lot of politics and real world things going on inside. So you please.
I've sort of been involved both over time and in a variety of different kinds of archives, and actually with the software and archiving the software and documenting it appropriately too. And it just seems I'm glad that you're looking at the whole infrastructure because there's a lot of it, and I think a lot of it's not looked after very well by the people who are dealing with the data, either taking it or using it. I think all along the way there's a huge lack of documentation of what's happening because people shrink it to put it into papers and sort of the original ideas get lost. So I don't know, I've been trying to encourage people. One of the things I'm involved with now is figuring out what comes after FITS. Okay. And how to, yeah, I know, we're talking. Good. But one of the questions is, how do you get people to agree on things, on standards? How do you get the actual astronomers to agree? People that are dealing with the archives have a different goal than an actual working astronomer does. And I'm finding for moving forward into data formats that just trying to get all the people that did FITS are retiring or retired. And
Arnold's sitting here.
I know he's retired.
Okay, I know. But just to point out for those in the back can't see.
Yeah. He's retired.
But
So
it's
I-
here.
Right, so I'm feeling like we're the last people from the first generation standing, and the next generation hasn't learned about the standardization concepts, even like agreement, mutual agreements. And I'm not sure how far you have to go into the newer science before you know what you want to agree on. And that, do you have any sense of how the process works as you move forward?
Can I let you think for a second to answer that question? And I want to ask a different question. Raise your hand if you're a graduate student. One person in this room is a graduate student. Two? Sorry, I can't see the other person. Okay. That's, oh, Bernie, you don't count. Okay. I just granted you a PhD. No, it's because I meant in astronomy. And I think that's part of your point, right, Jessica?
Yeah, it is exactly
Okay.
that. It's, I mean, I've seen people now postdocs, and I mean, I'm having a hard time figuring out how to go forward.
Yeah.
And
This is the continuity point, and that's why I put up that chart, is to show that there's a whole lot of institutional knowledge, and given how many of these pieces were built in the 60s, 70s, and 80s, and these people are retiring, the wealth of knowledge in this room is mind-boggling, and these people are going to retire too. And we've got to carry this on because it's invisible work. This is where you get the breakdown. Is people say, oh, it's just there, it's going to be there, without realizing it's not just going to be there. unless somebody makes the investment that this generation made mass investments for this to be here over time. And with standards is a big issue in science and technology studies because it's how do people reach agreements. And there's the usual quip of the good thing about standards is there's so many to choose from. But the other part of it is it takes years to get a community to agree on a standard, and that is about 10% of the labor. The other 90% is actually getting it adopted. So the uptake can be very slow, particularly in fast-moving technological fields. So this is why the FAIR principles are such a challenge. What does interoperable mean when you've got so many moving parts? So we've got the institutional memory, and we've got the lack of care. Let me make one more point because I want to get some questions, which is that the notion of the data set is also extremely messy because any project, any observing night, any set of nights will get sliced in different ways. A one-to-one map between a data set and a paper. I mean, but say between one clinical trial and a paper, you also don't have a one-to-one mapping. So saying what are the data with any particular project or any particular paper is a non-trivial exercise that we have some very good librarians who are spent their lives thinking about. But there's even the notion of what two things are the same is something that goes very deep into philology and philosophy. So when you start cataloging two things as being the same, you're opening up a whole epistemological question. Following back.
So when I look at what you described as the public data, and for example, let's take the China data archive. Those are officially massaged and calibrated. So there's an enormous amount of work which is going into calibration of data, and that is, if you were to compare the organization of the China archive to the organization of calibration, it's miles apart. The calibration is treated as science projects. They're done by scientists who are half-time scientists, half-time calibrators. I don't know that there's enough value put on the stewardship aspect, so that there's always a rush. You got to get your calibration products out. None of that is archived. None of the procedures are archived. People write whatever software they can to get their job done. So there's this vast, dark basement that as much as we want to do all these wonderful things like public-facing data, I mean, if I were to go back to an earlier mission like Rose said and try to find the calibration data, find the procedure, it's completely impossible. I can only rely on what the data that are in the archive. I can't tweak anything or anything like that. Right. And I don't know what it's like on archives of optical observatories, but I don't know if you archive the dome flags, you archive any of the calibration data. So I think that's like, that's the bottom of the iceberg that we're not paying attention.
That's the fragility. That is the underbelly of the data sets.
And I think there's a value judgment that this community has made, which is that it doesn't value that as much. And in my mind, I think, I'm biased about this, but I think that astronomers value the instrument makers at a different level than they value the people who are doing the actual research. And I think that sort of a cast has continued over the years where we're talking about the people who are moving the data around and calibrating. And in my mind, I think that has to change.
Well, this is what I'm hand waving over as invisible work. That is absolutely critical because just like the software, if you don't have the calibration, you don't have the context, you can't really interpret and reuse those data. And that's part of the subtext of what we're looking for is if you start with a question of what's required to reuse a given data set, for some purpose, and then start to work backwards of where those data came from and all the knowledge products that are associated with it. The calibration comes up very quickly, and we learned that way back in the early 2000s. I spent 10 years with the Center for Bed Network Sensing, the NSF Science Technology Center, and we cut our teeth on a lot of that. And the calibration questions were ones that really brought the signal-to-noise differences up between the fields of the one person's signal with somebody else's noise. Who was paying attention to what? But we're seeing that not only in calibration and astronomy, but we're seeing it in areas like even some of the black hole work, where the gases are noise to one group and they're foreground signal to another group. And what one group's trying to delete out of the background, another group's trying to pull into the foreground, and those kinds of choices. So those are scientific questions, and again, that's what we're looking for. Is those scientific questions are then driving what gets kept, how it's described, how it's marked up, and those in turn create path dependencies of how those data can be reused by whom in the future for what purposes. Let me get Arnold and then Greg in the back.
But it goes beyond just the calibration. If you have an archive that's still in development, still growing, you will have a group of people behind it who understand the software, who understand the instrument, who basically understand the whole machinery that makes the archive. And that expertise, that technical and scientific expertise, is absolutely essential for good use of the archive. The worry is how do you retain that? And that goes also beyond just having the software, the documentation, or even the calibration information. Is the Achilles heel of finished archives. And you can go one step further, and that is if you're thinking about the bibliography, the links between the data and the literature. Sure, you can maintain that and expand it and keep up with it while the archive is growing. Now, what are you going to do when the archive is sort of put away or is considered finished? How can you, at that point, continue maintaining your bibliographic database? Another touchy point.
It is. But there's a number of distance issues here from the point of origin of the data to the reuser. If it's two people in the same room at the same point in time, they can talk to each other. If it's two people within even different places within, say, a year, and the team is still intact, they can talk to each other. The farther you get away in time, in distance, in language, in culture, in topic domain, and we've been looking at a number of different dimensions. The farther you get away from that point of origin, the harder it is to have that communication and the more context you need. So we have a paper that Irena's the first author on, came out last year, on just the whole notion of reuse and what that means and how that.
Do you retain the expertise?
And or can you retain the expertise, and how much can you actually document such that once the people are gone, once the expertise is moved to Florida, whatever, can you keep it going? Let me get Greg Crane in back, digital humanities expert.
So I'm fascinated from the nature of how you manage a fundamentally international weight set of data sets. My pragmatic issue, I have a professorship in the US and in Germany. I submitted a proposal to the Germans. They say, yes, we don't care about CERN. We have to have a German organization. We will treat this as a national project. And the fact that the Americans have spent money is nice, but you get caught in this box. When I see Strasbourg interacting in real time with France and the US, how do you do it? How do you navigate or create political understanding to to manage a sustainable international set where no country can fail at.
Well, and that's what's fascinating about astronomy. We've not seen any other field that's been able to do that. And I think it's often astronomers don't realize what they have accomplished in that sense compared, the biologists have been able to do that. Some of the genomics they've done that, but even not, as far as I know, not anywhere near as much as astronomy has. But I think there's people in this room who can explain the history of this, but it goes back generations.
Well, Alberto and Michael can explain the history best, but I had a different question. I have a question that's related to that, which is in Europe, if you go to use a credit card, an American credit card, and you don't have a chip in it, they laugh at you.
Right.
Okay, and the reason that that's true is because they leapfrogged us, and that's why their cell networks are better or whatever. So we were ahead, but then they skipped to the next generation while we're stuck with this huge installed base.
Right.
And so my question is, astronomy, thanks again to ADS and CDS and all these things, is this leader, and I do appreciate how special astronomy is, at least now. But as you know, just yesterday I was at this meeting with a bunch of genomics people, and I was hugely impressed with what they've done in like the last 5 years, and they've made the chip readers. They've got like better credit cards. Okay, and so what I'm worried about is, do you see that? I mean, like if you look at the other fields, they historically were much worse than astronomy. But if they go and skip to, we did everything in the Amazon cloud, and we use Jupyter Labs, and we do et cetera, and they're like totally modern, and we're just with our giant installed base, are we in trouble?
Well, nobody should be too comfortable about their position.
Yeah.
Which is, again, that's back to our questions about the fragility. It's working really well, but none of this stuff is. Technical infrastructure does not survive by benign neglect.
Right.
You can't just it's not put.
But also doesn't survive by just maintenance of the status quo.
It does not. No, it's you got to keep moving it forward in different ways, but you've got to keep that interoperability moving forward.
Right.
Let's get Xiaoli and then Charles.
Just as I say, if you go to China, use credit card, people laugh at you. They're using them.
That's true. Thank you, Shelley. That's 2 generations. You're
I
right.
can survive it, but I don't
No,
have a
watch.
comment. But the serious question I have is that when I was trying to work on, kind of set up some statistical theory for pre-processing, which is really under the past dependency issues, I run into 2 major difficulties. And one is more sort of sociological, that all my colleagues, all my friends told me, like, Kelly, don't touch that problem. It's just too messy. Like, you need to require you to know so much about what other people do, like how the data clean, all those things. So it was just sort of almost hopeless. But I think that the other problem I faced, and I could not find a single page, is anticipate what kind of analysis will be done on whatever data you have needs. And then we don't even know how to go about that question. But without knowing even a rough idea of what these analysis will be done, and you can't really meaningfully talk about this, what it seems to me, because I don't know what will be done. Right? We're all guessing. I can't even find one single paper to even think about that kind of question. My question is like astronomers or other fields, I kind of question maybe the way you study them that we can learn from them.
I have a paper to refer you to from National Snow and Ice Data Center.
Okay, great.
Data Center on exactly that point, and the people in the front row know what paper I'm talking about. We've also found that the people who create the data are the least useful in telling you how it could be used. The people who create the data can only imagine being for the purpose they created.
That's right.
They're not they really can't think about what the other uses are. So this is back where do you want the librarians to decide? Do you want the scientists to decide? It's that anticipation problem is really, really hard. The Snow and Ice Data Center paper is where it took them about 20 years to have enough data to really see about the melting ice. But it was built for volcanologists, people in that particular area. And once they had major findings, then because everybody in climate change want to access those data, and they had to completely rebuild it, a whole new kinds of metadata, provenance, audiences, and it's a really interesting paper. I'll send it to you. Charles always gets last word.
Well, let's ask about money. Like, because historically, what institutions have succeeded at in keeping things viable for a extended period of time is what we call libraries, right? And institutional money went into it, Harvard endowment money goes into Harvard libraries. Part of the indirect costs we collect on our research grants goes into our libraries. We don't really yet have a mechanism analogous to that for curation of data where the project that created the data has completely gone out of business, right? Whereas historically, if you wrote a book, you got it published, you handed it over, and you were done, right? You had no further responsibility to make anybody else get access to the book, the publishers and the libraries. And part of that was just, tradition and work, but part of it was money. Right?
Yeah.
We had a way of paying for things, taking care of things that were created by other people. And as long as we think about preserving the knowledge, the human experience of the project, we're going to be stuck to that model. We have to think of a model which completely separates the data from the people who created it in order to succeed. And we may just not be old enough for that to have happened yet, right? So, sometimes I hear the term orphan data, and those are the data that matter. in this
Right,
discussion,
yes.
Right? It's the data whose creators have lost interest in it. Gone on.
Well, that's, let me answer Charles, and it's up to you if you want to stick
There's
around.
a lot of half raised hands, and so I think we should have just a group little private discussion afterwards, and this should be the last question.
Okay, so whether we can describe and curate data in ways that they can more or less sit on a shelf is a giant open question. And one of the things that we're finding, and it's part of the Revis dissertation as well, is that there's certain kinds of reuses of data that are, so if you want to reuse them for calibration, ground truthing kinds of comparisons, you can go get them off the shelf and compare like doing literature review. But it's when you want to go back into those data and ask new questions or combine old data with new data, that's what's very hard to do without having a conversation and a collaboration with the people who created it. There's a level of kind of deep, tacit, explicit knowledge, not only about what was collected, but why it was collected, what the scientific models were behind it, a level of documentation that doesn't get into the scientific papers, doesn't get into the scientific process. And whether, it's also a matter of how much we want to invest at the point of data creation to make them useful for the long term, as opposed to getting the data out in papers and getting the papers circulating faster. So it's a very long process, but that requires more upfront investment, which there's not enough incentive for right now, I would say. But the librarians, unfortunately, Dana stepped out before you asked that question.
Sorry.
But she's very much, she's on top of that, and certainly, my role as a professor of information studies has been trying to build a generation of people coming out of the library archives fields who are very attuned to how data is different from publications, where it fits in the scholarly process, and how we can keep these products alive over the long term. We need a big workforce, big human investment. But like you're saying, we should have room for graduate students and postdocs talking about these investments.
I don't think they realize how important this is until you have to be old enough to have lost some stuff or not be able to find stuff.
Because I think it's building it in the process of the students and the postdocs to get them to see that their future careers depend on being able to collect their data in ways that they begin to see them as assets for themselves and their community. And that's
That's interesting. Well, I'll just say one last thing and then we'll thank you, Chris, which is that if we advertise, and we've done this in the past, to talk about software, this room would be filled with young people.
okay.
And so going back to Mercedes' point, I think that there's often a divide in people's minds between software and data, and one they think of as modern and important and changing, and then the other one they think of as like they could put it on the shelf and they'll just get it later. And they don't realize what the connection is between the two. So we have an educational job. You got a month to do it. Thank you very much, and thank you for coming.